Hello everyone, I'm Arkabandhu Chaudhary. Today I'll be talking about my work titled Meta Classification for One-Shot Learning. This work was done in collaboration with Deepak Chaudhary, Swarat Chaudhary and Chris Germain. In our work, one-shot learning example is image classification. So here is an example of one-shot image classification. We have one example of training data. Here is an example of buffalo. And then we have multiple examples of buffalo as well as other categories for testing. So this is an example of one versus all one-shot image classification. The existing approaches, they are direct supervised learning, for example k-nearest neighbor. Then we have unsupervised learning, Bayesian approach where we have Bayesian prior and posterior. Then we have metric learning, meta learning, so that is the most popular one, and here we have metric based, memory augmented and optimization based. Examples of metric based are Siamese network, matching network. Memory augmented are memory augmented neural network, simple neural attentive meta learner. Optimization based are optimization as a model and model agnostic meta learning. This is a typical example of meta learning input where we have one positive example, multiple negative examples, that is our training or support dataset. Then we have our testing or query dataset where we have multiple positive and negative examples. This is another example of meta learning input. Our method learns to produce a set of k different learners. Each learner has high bias and low variance. Also, each of them has a scoring function and its own training algorithm. Then a meta aggregate function sits on top of these k learners, combines all of them and then produces a final outcome. We can show an example with 3 learners. Each of them has a training algorithm of its own. Then we have the training data of different categories. One sample task is one-shot classification of airplane. So support image will be one image of an airplane. Query image will be different airplane examples and other negative examples. So first, all the sample task is fed to k learners, here 3 learners, and then there's a task encoder that will encode our support image, and then we have the encoding as well as the outcome from the learners to a meta classifier, which will eventually produce the aggregate scoring function that will predict whether an input image is airplane or not. So what is the difficulty in this approach? It's an unsupervised approach, so it tends to converge to a single learner. In order to avoid that, we can cluster the problems first and then do the gradient descent. So here's an example of a dataset. We first clustered them into multiple categories and then feed each category to its respective meta learning algorithm. And then we have the sample task and there's the encoder, and then we feed the encoding and the outcome of the meta learners to the meta classifier as before. These are the experiments we have done. We have used Meissner dataset, Caltech UCSD bus dataset, Omniglot and aircraft dataset. These are the comparative methods we have tried. We have used MML and ensembles of MML, and then our method and the clustering and nearest neighbor model. These are the results we have. In ImageNet data, we can see our method has significantly higher accuracy. As we increase number of clusters, we have better accuracy. This is the cross-domain results, this is Omniglot results, and this is aircraft results. As you can see, in all of them, our classifier gives much higher accuracy. One thing to notice is that if we keep increasing number of clusters, at some point accuracy will go to a steady state, so we have to find the optimum cluster number. In conclusion, we saw MCMC learns a set of learners tailored to different problem types. An aggregator looks at a particular problem to combine the learners to solve that problem. To facilitate computation, we can use clustering to group the learning problems first, and this is extendable to other types of meta learners and data. These are my references, and I'll be happy to talk more. This is my email ID. Thank you.